we're talking about measuring continuity, and so I've got the meter set on the lowest resistance range, and you can see there's infinite, or that 1 up there, obscured by the little mark blemish on the screen. And then we'll short it out, and you should see something that is 00 point something, 4, something like that. 00.4. Okay, again I'll open it up. You'll see the meter change to that 1, which indicates infinite resistance, and short it out, and you should see about 00.4, 00.3. Wouldn't worry about too much other than just 00, and you may even get up to 1 or something, depending on the meter and how it's set. If you've got a dial meter, it'll show somewhere down toward 0, and in some cases they actually have a 0 potentiometer that you can adjust on the side and 0 it out. So, okay, that's pretty much it. I did talk about resistance in the higher settings and through your skin. I'll just quickly go up to the 2 megohm, and I'll take one and put it in this hand, and I'll put this one here, and you'll see we got numbers bouncing around. 800, 700, so 800, 700,000 ohms, 700 kiloohms. So 800, 700, I'll let my finger go, and air, you know, is infinite. Well, not infinite, but close. You do get lightning and things like that, but that's a whole nother topic. I'll touch it again. So there is some resistance in my body, but this meter becomes real sensitive when it's up in the higher scale. That's why if we're doing what we're doing, short, open, always set on the lowest number. Okay? Alright, next I'm going to move to capacitors. Now, there's several very good videos, YouTube videos, talking about capacitor testing or identifying blown capacitors. Turns out that electrolytics, blown electrolytics, and I'll explain that in a minute, is a big issue with TVs, various digital TVs, digital displays, and that sort of thing. And the power supplies, and this power supply here. This power supply is out of a desktop computer, and or desk side computer, and it was one that was actually got bad, and I had it in my shop, and I really never troubleshot it, but I'll do that here while we're sitting here. So to some extent, I'm not going to change the part and get it up and running. That's not the purpose of this discussion. But there's several good videos on YouTube under bad capacitors, or look under digital repair of digital displays, and in fact digital TVs. There's some of the digital TVs, they have the same kind of power supplies in them. Okay, capacitors. You probably have heard that term, and what it refers to is a device that holds and stores electricity. Minute amounts, but it'll store electricity. And there are some capacitors that can store a great deal of electricity. So one of the things that I must say first is you got to make sure that the unit that you're dealing with is discharged. This particular one has been out and it's been unplugged. Still could have some capacitance or some voltage left in the capacitors, but I've gone through and discharged it. Now, the best way to do the discharging is short the ends of the leads in the capacitor with like a light bulb. Some lower resistance item, a resistor would work good, a 50 ohm resistor if you had something like that, 100 ohm, even 1,000 ohm, just something to bleed that charge out of there. It's not, it's just a precaution. If you're dealing with anything that does high voltage circuits, like in a CRT, cathode ray tube, or an older television that had the tubes in it, the cathode ray tubes, those things can get pretty powerful, and you need to be really careful around the high voltage portions, several thousand volts, and you can get zapped pretty badly. So capacitors, these little blue guys are capacitors. Okay, I don't know if you can see that. These little blue guys, button capacitors, and these big guys, these are called electrolytics. This happens to be a 200 volt, 50 microfarad capacitor. Doesn't seem like a lot. 500. That may be a 500 microfarad. These little guys here are also electrolytics. Electrolytic is referring to the fact that it's usually used in a power situation, and the device inside provides the capacitance, uses electrolyte, some kind of a liquid or a paste or something to provide the storage potential. And these guys, all of these, you'll notice, well, these guys don't show it, but there's a paper cap, and underneath it is the aluminum case that this thing's built in, which is essentially a couple of pieces of film with something like wax paper in between them. In fact, the old capacitors used to just be film, like tinfoil and wax paper. But these have a chemical in them called the electrolyte, and that's the term electrolytic, where they come from. Now, you'll notice that there's this cross in the top of the aluminum, and that's allows for any pressure that builds up. Now, and when they do build up pressure, meaning it's starting to short, it'll heat up, it'll start vaporizing or providing moisture or steam pressure in there inside. Before it blows, it'll bulge. It's made, those creases are there, so it'll show that it's starting to bulge. And these all look pretty good except this one. There is a bulged one here, and that one I would say is bad and should be changed. And that may be the reason this thing didn't work. So, in fact, I think this particular one, its 5 volt circuitry worked, but the 12 volt circuitry didn't. So that's most likely the cause. This big guy here, I can't see it, but it has a little bit of a dome. Yeah, so does this one. So these two guys, big guys, may be a problem, but I don't know. But I'll show you how to check reasonably well. I'll look through all the rest of these. There's about, I don't know, 15. All these little guys here are all also electrolytics, and they all have the same kind of, well, these don't have the scoring on it, the little cross on it, but they're all the same kind, and they're subject to the same blowout problem, and that is you get a short between a couple of pieces of film, as if it was like a piece of wax paper. It starts to short through. Once it starts to do that, its resistance starts to go down. It heats up a little more. Once it heats up, it starts to degrade a little bit more, and it has a the system runs away, and it heats up a lot, and then poof, eventually it'll blow. And most likely what happens here, it just shuts the system down. So, okay, now, when these guys go, most often, not always, but most often, they short out. And that's what's causing the heat to generate the power going to them, causes heat across that short, and that's eventually what blows them. But they don't all blow. The circuitry or the fuse pops or something first. Or it takes out a transistor or something. So what we're going to do is we're going to check the continuity of the bottom of these capacitors. And a good one won't be shorted. It may show, I don't know, 500 ohms, 1,000 ohms or something like that. And when one of the indicators with a meter like that is, you'll see the resistance measurement change over time. And what's going on there is your battery and your meter is charging those capacitors. So